Again, I want to thank everyone for joining today's webinar. Today's presentation is with Servomold. It's titled Motion for Creation. We have a great presentation for you guys, and today we have Richard Gain, the Chief Sales Officer from Servomold. Before we begin, some quick housekeeping items. We'll be taking questions throughout the presentation, so if you have any questions, please put them into the chats, into the Q&A section, and we will pause in the middle of the webinar, answer some of the questions, and then continue back onto them. We will also have a Q&A session towards the end, so if there's anything you want to ask or anything like that, for both Servomold or the DME team, we are all available for you. Other things that we have, if you haven't already, please follow us on LinkedIn. There you'll find all the information about DME, all new events, new webinars. And also we have our social media on YouTube. There you will find past webinars and product videos that we have. Other than that, I guess I'll hand this over to Richard right now, and he'll talk about motion control.
Thank you very much.
Where's yours, Richard?
Thanks very much, Mark. And again, from my side also, thank you very much to everybody joining in this. I realize it's Tuesday morning, and we'll try and keep this as interesting as I can. As Mark mentioned, we're doing Motion for Creation. We've been partnering with DME for now over 5 years. DME is our contact people, all of the sales guys around North America, for finding out more about us. So please feel free to reach out to them at any time. So I'm going to start off the plan for today really is to make as interesting as possible webinar presentation to you. Not too many slides, not too many writing. I'm going to try and show you an overview of what we do, why we do it, and why this could be interesting for yourselves, depending, of course, on your positions, whether you're a design engineer for a mold making company, whether you are a mold maker yourselves, or whether you're a molder. This should be interesting for all of you. And as Mark also mentioned, please feel free, put up a raised hand at any time. And I've got quite a few positions in the presentation where I could easily stop and answer them some questions in case somebody wants to get it over and done with straight at the beginning. So I'll move straight on to my very first slide, and servo technology is offering new possibilities. So new possibilities, what does that really mean? And in a nutshell, the servo technology, you have control at every level. Control of what? What does Servomold do? You have a little bit of an overview there on that page. You can see lots of pieces of equipment that we make. We have equipment that will unscrew cores, move slides, turn index plates, anything that you want to move in an injection mold, in or around a plastic injection mold, we have a solution to be able to do that. We help you at the very beginning. Now, obviously, those of you who are already customers of ours, you'll already know about the support that we can give. But those who don't, and particularly those who perhaps haven't used servo yet, or they're using their own servo, or they're buying servo motors, building their own gearboxes, building their own cores, rack and pinion systems, or whatever. What is it that makes us so special? Why should you actually come to us instead of doing all the design for yourself? Well, firstly, we will support you in the actual decision of exactly what unit, what size, what design, what concept to use. There are many, many ways. Those of you who are in mold design will know yourselves. You can design a mold to make one particular plastic component in a variety, 10 different ways easily. They would all work, but you need to find the most efficient system. And we are there to support you, help you make the decision for which motor to use, which gearbox to use, which concept. Do you want a rack and pinion to unscrew cores? Do you want a gearbox? How many motors should you have? We'll make the calculation at the beginning. Will it work out exactly the demolding forces required? Obviously, we make the calculation with past experiences, but also with our own software, which we've developed, where we can very accurately work out the amount of unscrewing forces or demolding forces that you'll need. And on those information, of course, we're taking into consideration cold. The injection mold is finished. You've molded your part. It's been left overnight. Then you need to unscrew it, or you need to move the slide out. We take all these considerations or all these factors into consideration, and we'll give you the concept, the calculation, and the design for what you need. The second point is manufacturing and assembly made in Germany. We're very proud to say that all of our gearbox equipment, and at the end of the day, this is really what we do. We marry together an electric motor, a spindle system, with our gearbox. We have many, many varieties of gearboxes, and that's what we do best. This is what we make the best of. We make these gearboxes in-house in Germany, in a little village called Erbach in Odenwald. It's you can look it up on Google Maps to find out where it is. It's very easy to get to, as long as you don't mind driving through lots and lots of villages. But we make everything there, and all the components that we fit to our gearboxes and attach to the whole system is purchased in Germany. It's Germany or EU. Of course, we can't always guarantee bearings, seals, where the actual company who we're buying them from, where the manufacturing, we don't really know. But we have close contact with all of our suppliers, and intimate contact with our suppliers over many, many years now. Third position, plug and play. It's a very well used expression, plug and play, and I think we all know how that can be with plug and play when you buy yourself a printer and you plug it in at home and it doesn't usually play. We really do endeavor to give you plug and play, but there are always anomalies. There are always applications where you're going to need support from us, which basically takes us over to number 4, the commissioning and training. This can be done through DME. DME have engineers who can support you in-house. They'll come to your factory, to your mold shop, or to your molding shop and help you commission this system and get it up and running as efficiently as possible. On top of that, we can also support you online. We'll do Teams calls, we'll have cameras set up, and we can help you set up your system as efficiently as possible and give you the support that you need at the very beginning of what would be an efficient, in your first idea of quite a complex system. Now, that was the overview, and I want to go into a few solutions, what the solutions that we have. But at the end of the day, whatever solution it is, we're aiming to deliver 3 results. It's precision, repeatability, and simplicity. For any movement that you have in an injection mold, we don't want to make things more complicated. We don't usually make it cheaper, and I really need to point that out. You don't buy an electric system instead of a hydraulic cylinder and think you're going to save money. You as a mold maker. The end customer, your customer, they will save money. They will save a lot of money. And this is the position where you need to be, and this is where we want to help you understand what we've got and help you explain that also to your end customer, the molders. What are they getting with these systems and these solutions? So first off, we've sort of divided our offerings into 3 subsections, if you want. We have the linear activation. So this is the movement of slides, racks on a rack and pinion system. We have unscrewing rotational devices. This can be unscrewing cores. This can be index plates, anything that needs to be moved in a rotational manner. That is our second section. And then, of course, equally as important, and without it, the other 2 aren't really going to work, is our controls, controllers, control systems. All of it from us. And I'll kick off now with linear. So I'll let this little video run a bit. Hopefully it will smoothen up on my laptop or on my screen here. It looks great, but that's it's got to go a long way. It's quite a few kilometers for it to travel until you get it. So hopefully this is smooth, at least on the second or third loop. But what we're showing here is, and it's quite a simple acronym, SLA, servo linear actuator. So you have a servo motor, you have a gearbox, and you have a spindle. And you can do anything you want with that, or whatever you think you need to do in an injection mold. We're showing here a very simple slide movement. This can equally be done with a hydraulic cylinder, of course. Nobody would say, well, I'll take the hydraulic cylinder off and put an electric motor on because it's fun. There's got to be a reason for doing it. The reasons are very, very clear. If this mold is running in a clean room, then the electric motor is going to be a no-brainer. You're going to probably, as a molder, you're going to demand that. As a mold maker, you will be demanded, there will be the demand to use servo electric for your slide movements in clean room facilities. We're seeing a lot of customers worldwide who are buying more and more full electric injection molding machines. Unfortunately, I say unfortunately, that's just me. There's the odd application, and I hope I don't step on anyone's toes here, where they've bought a very nice full electric fan-up machine and fitted a little hydraulic pump underneath to keep their hydraulic cylinders running. This is a low investment, and I completely understand the motivation to do this. Long term, it's not the best solution. You've still got hydraulics, you still have risk of contamination, of leaking oil, and as we know in the medical industry in particular, contamination of parts in the bin. The whole bin needs to be thrown away, scrapped. I have customers here in Switzerland, one very big medical healthcare manufacturer. If they're running a night shift and there's one drop of oil drops down into the free fall bin, the whole shift has to be thrown away because they don't know how many other drops of oil has dropped down during that night shift. So that alone is making such a saving by having it running full electric and totally clean. The second advantage, of course, of running it now instead of my hydraulic cylinder, and I like to use that expression, the hydraulic cylinder, it's like a bulldozer, basically. You give it power, it pushes the slide in, and that's it. It clamps up full force, relax, it's always sort of full pressure on, then you pull it back. There's a lot of motion. There's a lot of very aggressive motion going on in that injection mold. This increases your wear and tear. And with the electric system, with the controller that we're supplying, even if you're running the electric system over a controller integrated in the injection molding machine, which is also possible. Obviously, we prefer to use our controller. There are certain advantages, but it's not impossible to do it. You have control. You can control the motions. You can control your ramp up speed. You can control your ultimate moving speed, and then you can control your ramp down speed and your soft close. This still happens extremely quickly, but it's far, far softer, far more mold protecting, and will give the molder, at the end of the day, a longer cycle time between maintenance. Obviously, is a saving. I keep saying this, the molder, because it is, at the end of the day, the molder who's going to get the best advantages from using these systems, not the mold maker. But many of you are mold makers, and you need to be able to explain this to your end customer when you're offering these sort of systems. Please feel free to reach out to us. We're more than happy to help you. We've done this with many of our distributors worldwide, where we've supported and explained in detail to the molder what they're getting, and then they're far more willing to make that jump to full electric. And I'm absolutely convinced, and it's happened time and time again, once a molder has made that jump and moved to electric, they won't go back to hydraulic. This is the way forward. So enough of me ranting on about why. What we've got now, an SLA, and again, just come into my mind, actually. I don't want to just carry on blabbing on. This is an overview And Mark Zaboni and I were talking this morning also with our marketing people. We are keen to do a series of these webinars. I'm going to show you pretty well everything, but it's a huge amount of information to take in one webinar. And in the future, during the year, we'll do more of these webinars where we can go into more detail about one particular thing. And then there'll be far more time and opportunity for more questions and answers about certain technologies where we'd be really happy to help you out and support you in that decision making. So SLA, servo linear actuator, made up of 3 parts. We have the servo electric motor shown at the top. Use my little laser printer, obviously, for everyone. It's the servo motor. At the very bottom, we have the spindle. Now, the motor, we buy those in. We don't build those. We concentrate on what we do best. And this is exactly what the mold maker needs to do. Concentrate on what you do best. Cores and cavities, mold designs, plates. Most mold makers are buying their plates in now, pre-machined. We do the same. We buy in our electric motors. They're from Europe. We have a couple of suppliers. The spindles, again, from Bosch Rexroth, German supplier. We buy those in. We can buy those any length. Now, those of you who perhaps have already used linear actuator motors from our competitors, there is an American supplier, manufacturer of linear motors who we have also been selling up until recently, but struggle selling them now because of delivery times. But basically, our competitors will have a spindle which is running through the middle of the motor. This has advantages, it makes it far more compact. However, as far as your spindle stroke is concerned, it totally blocks you back to how long my stroke is going to be. If you need a stroke for 200 millimeters, you need to buy a motor that is proportionally longer than if you would have only a 100 millimeter stroke. With our units, we have different sizes of these gearbox, depending on how much power you need, how much torque you need. Alongside that, we have different motor sizes, again, giving you different power torque curves. And the spindles, they can be at any length. So in effect, if you need to move a slide, a silly amount, but who knows, 300 millimeters, but it's only a single slide with one core on it, there's hardly any forces needed. You could use a small or extra small gearbox, which has a particularly small footprint, small motor, and a nice long spindle to go with it. All the options are available. So, as I mentioned, we concentrate on what we do best. This is the gearbox, the actuator itself. This is an example of one. There have been many updates of this particular piece, this particular unit. This is nearly the last one, but I can't keep up with my presentations with the very latest, but I will be updating it. As far as the presentation is concerned, the concept is identical. We just have a few small iterations, but always trying to make the units that we build as efficient and as low maintenance as possible. The goal in building gearboxes like that, and this is, as I said, I'll mention it again, this is where we are specialists. Our goal is to make these units as low maintenance as possible. What's low maintenance? Obviously, it's always, as everyone always says, it depends on the application. Of course, that isn't the answer you want to hear. But if you're running in a clean room, for example, and you're moving a rack and pinion system, a couple of million cycles is easily within reach before any maintenance is needed. If there's any maintenance needed, or when it's actually, many mold makers or molders will put down a mold service interval anyway, and it's usually before 2 million cycles are up. Then a little bit of greasing will be done. You don't need to take these things apart. You'll need to do a little bit of oiling on the spindle nuts. We give a maintenance manual, comes with this. It explains how to do it, very clear photographs and drawings explaining what to take apart, what is necessary to take apart to be able to do the work. Very, very low maintenance. So that's basically the highlights of the SLA. And this is for servo linear movements. We were approached a couple of years back by a large medical manufacturer, medical device manufacturer here in Switzerland. I'm actually sitting in Switzerland now. They were building molds with a lot of lift and strip concepts. Now, lift and strip, most of you will know what I'm talking about here. It would be a tubular plastic component. They're anything between, I don't know, 40 millimeters long and 100 millimeters long. These parts are usually within the body, within the unit of an auto injector or a self-injecting device. This particular customer approached us. We've been setting SLAs to move the slide. Obviously, as you saw in the previous video, we use these, attach it to the side of the mold, move the slides in and out. This particular customer said, yeah, that's all very well, but I still got to make the slides. There's a lot of parts in a slide to make a slide really accurately. In effect, with no free play, but it still needs to move, is really difficult. And they wanted high accuracy for the cores. They wanted to have the cores always in the exact right place. And we put our heads together, Servomold and this one customer, and we came up with the servo linear actuator SLY. I'll let this video run a couple of loops. Feel free to look at it. There are a few sort of intentional, not errors, but intentional design features that have been put in here where we cannot, obviously, we have NDAs with our customers. We can't say exactly how mold designs are done, but we can support you, and we would need to support you. You would require our support when using one of these SLYs, servo linear activators. Now, I'll move my little laser pointer in here. As you see, you have a core retainer at the top. That core retainer, obviously, we're using different lengths cores. We've got a short core on the right, long core opposing sides. This was for reasons of balance. We have demolding forces. And by doing it like the way it's designed, as you see in this loop, you see that the forces for the left and the right hand SLY is always going to be the same. It isn't that we have all long cores on one side or short cores on the other. But these are details which we can talk about if this is something where you think this could be of interest to you. What we've also, I mean, myself, I'm a tool maker. I studied as an apprenticeship as a tool maker many years ago. I've been working in the plastic injection mold industry for many years. And the standard way for these sort of components would be to stand them up and put them in what we say in German, a form. This is basically slides, to a left and right slide, the part standing up on a core. You inject the part on the top and then just have a very long ejector sleeve pushing the part off. This makes for a very large mold, a lot of moving parts, a lot of maintenance, and not really the best injection point. I think we all know, those of us in injection molding industry know that the nicest place to inject it would be as the part lays down on its side, a thicker area. Particularly here, you can see we've got a very close cavity pitch. Sometimes if you have a needle valve system, you can't get such a pitch. And that's another reason why we've gone left, right, left, right. We've actually staggered the injection points so that the hot runner system is also staggered. But basically what you hear is a lift and strip. We're building the whole slide unit ourselves. So we're supplying everything that you see there moving, other than the cores and the core retainers, is made by us in our factory in Erben. I'll let this run again, a couple of loops, and it's basically showing you what an SLY is made up of. Very few components, but highly accurate components. Again, it's the same electric motor that we have in our SLY. It's the same spindle. It's a spindle from Bosch Rexroth, exactly the same. We have a nice push drive driving that spindle. Spindle's retained at the front over another bearing. The spindle is very well supported on both ends. Attached to the nut, and to stop that nut from turning, otherwise if you just turn the spindle, the nut will just go with it, we need to stop it. And that's this nut retainer that you see now, moving up and down. It's moving up and down a machined area in the bottom unit. And then the top slide is attached. This top slide is running on needle bearings. Needle bearings supplied by the company Schneeberger here in Switzerland. They're preloaded bearings, so it's a preloaded guide. Therefore, with the fact that it's preloaded, there is no free play. The top slide running across that, along that bottom slide, has zero free play. We guarantee, in fact, the position of that top slide on all areas, a maximum of ±8 micron runouts. Why does it need to be so accurate? Well, the idea is, if you have a lift and strip mold, you're going to be pulling cores out of a cavity after being lifted and with cores being pulled out, parts are being stripped off over a bush. There's no huge requirement for such high accuracies. However, when the mold is closed, when the mold is in the workbench, when the mold is on its back on the workbench and you're fitting the whole molds, those cores need to slide out extremely accurately. And these advantages of having these cores moving so accurately is that your core is being pulled out with zero deviation, causing you very, very little. I just saw a little admission for somebody wanting to join the call. It will give you an extremely accurate demolding position of those cores. In fact, this is quite a good point. Now I see that someone's put their hand up, and this does fit. This fits fine. Kevin, I see that you've got your hand up. Mark, you'll probably have to let Kevin speak.
I just gave him access to the mic. He has to unmute himself.
Okay, I got it. Thank you.
Yeah, cool.
Quick question. So on a typical slide, when we're pulling the slide back, we actually let it elevate a little bit so as we can prevent it from wearing out wear plates and such. So how do you address that with this? It appears it has to remain fixed.
No,
and I'm talking about the slide face, not your unit.
The slide face. Let me go back.
Or carrier.
Let me go back to here. Probably is easier to show, or let me show which bit you mean. Do you mean this surface face here?
So the slide itself, we'll call it. I'm sorry, I call it the slide body and the slide face, but it doesn't matter. That slide body, when a mold opens and we begin to retract it mechanically, hydraulically, any other way, it's typically elevated just slightly up against the wear plates. So my question is, with your fixed linear system, that's not going to happen. So what do you do in the wear plate under the main slide to accommodate that wear?
Good, very good question. This is where we would support you with the complete design. Now, we don't elevate it. It's fixed. If I click on it, hopefully it'll start moving. What you'll see, and you see my pointer, there are little black plates here. Yeah, you see it better up here. We call that a pressure plate. Now, the slide will take a certain amount of tonnage when the mold closes. Obviously, most of our clamping force is going to go over the heel surface here, where we're pushing the slides then together. The mold opens, and then, of course, you're right, you want to pull the slide back. You want to elevate it just to take it, lift it off of those wear plates. Yeah? We don't lift it. It has about 5 microns gap here this little wear plate underneath, and that's it. It stays where it is. There's no need for it to come up. The wear, because if it's a lift and strip, then you've lifted out of the cavity anyway. So correct me if I'm wrong, if you're doing a lift, then your core is out of the cavity, and then you'll basically just be putting the core back against the ejector plate, stripper plate. The reason, that's one of the reasons that we have this extreme accuracy of the position of these cores is there is zero deviation of that core movement. It pulls back in the exact line of draw, for want of a better expression, and won't touch anything on its way out. It isn't moving at an angle. The preloaded bearings in here will ensure that that top slide moves extremely accurately and there's no damage is going to happen. We purposely do not have any additional movements lifting the top slide off. It would probably,
if I may, if I may, so a typical heel for a slide would have clearance above the and so are you saying that you build that more accurate, or are there rollers or something on the top of the Gibbs is what I was getting at?
Yeah, we have, yeah, it's extremely accurate. I don't know if I've understood it correctly. The top slide is running over needle bearings on here. Needle bearings are fitted in here.
My apologies, sir, not your unit. I understood that. That was the whole question. The premise of my question is this is fixed in what we'll call mold close direction. And a typical slide elevates because the Gibbs that retain it have clearance under them, and that's for the wear. So as you spoke, when a mold closes, some tonnage can occur, and what we would define as the word hob eventually would go together. And so when I go, I know the tonnage is released when the mold is open, but when I go to pull this linear system out, I'm curious, do the Gibbs, or do you even require Gibbs in this, or is it dually mounted solely to your servo drive linear system and it's not controlled by Gibbs?
It's not controlled by Gibbs, if I've understood correctly. I'm trying to mix my English terminologies and the North American terminologies for mold parts. The Gib is exactly which part? Describe me the Gib.
That black piece you're discussing, typically the slide has heels on, in this axis would be on the top and the bottom of the slide.
Gotcha. No, there is none. There are none.
Okay. That was the question, because not elevating obviously gives in.
I totally understand you now. Yes. No, there are no gives. And this whole top slide, it's the roller bearings that I mentioned are in a V. So this top slide, it can't move. It can't move up or down. The top bit to the bottom bit. You can sort of see it here. You see right there, there's a little V. And that's where it's it's held in there. So that top slide is just moving up and down. It has zero free play. Now, not that that causes you a problem, because obviously we sold hundreds of these now in the market. What we have, for another reason, when that mold closes and you have the clamping force on it, and we push then the slides into its final position, we have on this part here small ball bearings, sprung load ball bearings, so that we push through the spindle here, this nut. The nut pushes this coupling, which is attached to the top slide. We push it to the closed position. Then the mold shuts, and those heels will push down, and then we just push against the roller bearings, sprung load bearings, rather than push against the actual spindle nut. It is designed so that there is, I think it can move over a tenth. It can move forwards and not have any extra stress on the motor, because in all of the systems here, you can, but it's not recommended to use the electric motor as a holding force for an end position. You can, like I said, but you usually then need to go up a size or two on the motor size. The motors, if they're under a continual power situation for a longer period of time, they'll start to get very warm. So then you would need to go up a size, maybe have it even cooled. But normally on a slide system like this, you would clamp down. And once the mold is clamped down, there's no more power going on the motor. It's relaxed, it's waiting. After your injection process has happened, mold opens and it gets a signal. And as soon as that signal comes, yeah, mold is open, I'm free of the heels, you can start your parallel movements. And this is another huge advantage of servo drives, is that you can do a combination of symmetrical moves. Symmetrical? Yes, I think that's the right word. I lost my English. Symmetrical moves, simultaneous moves between mold opening, slide movements. Your ramping speeds can be slower, but I've mentioned that already. That's with the SLA, it's exactly the same. You have complete control of your slide movement. It's measuring this control. You have the ability of having a window that you can program into your controller where you say, okay, I know this is it's a 64 cavity mold. I've got 32 cores each side. There's a lot going on. We have very large core retainer slides fitted to the top of the SLY. We have SLYs in different sizes, by the way. There are also wider ones. But I want to measure what's going on rather than the traditional hydraulic would be literally run to fail or run to leak or run to big bang. These will give you a signal. It's one SLY is starting to notice that one of the cores is sticking or something isn't going right. It'll give you a signal and it'll stop the machine. Either it'll give you a signal to begin with as a warning, say, yeah, powers are increasing, we're needing more power to make the movement, which during our setup, it was a lot less. Or if once it reaches a certain level, you can actually say, okay, if it goes beyond that, we'll switch the mold down. And then it will come to an end at the end of cycle, stop and give you a warning telling you where the power has been higher than it should be. I hope that's enough for now. Again, we'll do workshops or we'll do other webinars where we'll go into more details, and I'm more than happy to talk to you, Kevin. If you've got any more questions about that, we can take that offline anytime. I can get some of our design engineers to help out. I'm the sales guy. But hopefully I've been able to explain it clearly enough. And not to use up all our time. I don't know how far we are with this, Mark, because I have my timing is all muddled up. But I want to move on because we were approached again, and this is usually how it works with Servomold. We have very good communication with the OEMs, with high-tier mold makers who are discussing new design concepts of molds for more difficult to demold parts. And there's one particular type of part. Again, it's a long tubular part, but this time has a thread on the inside. So yeah, okay, you can do an unscrewing system, but we were approached and said, well, you know, it's got a rather nasty thread, and also the shut-off between the long core, which you see here, and the short core. It's really complex and it's quite delicate. And with any unscrewing core, one of the challenges in unscrewing devices, which I'll also get to in a few minutes, is positioning of the core. As you know, the rotational positioning, the radial position of that core, the start position of the thread, usually, if it's just a flat surface shut-off. But if you have a profiled shut-off like we had here, those cores have got to be extremely accurately positioned, which made the design of the unscrewing system extremely difficult and very maintenance intensive. So we built this in conjunction with our partner, this 4-cavity prototype mold. This is the prototype. We're going to 16 cavity after this, but it was a prototype to find out, can we do this? Now, We took an SLY, which I showed you before, and that sits down here underneath this top slide. And on the top slide, which is the exact same top slide to any SLY unit, top and bottom slide, you see them very clearly here, we fitted what we do best, a little gearbox. And that gearbox is extremely simple. All it does is rotate the cores, nothing else. It holds the cores. It actually keeps them in a cooled core system, which I'll show you on the next slide, where we actually managed to have cooling inside this rotational core as well. But it gave us a massive, massive advantage of being able to say, okay, these unscrewing cores, all they're going to do is rotate, nothing else. And if we're only going to rotate them, then we can position them extremely accurately. They're positioned over a gearbox, so they can't move. They can't have like a clamping plate to I have to adjust my core to a certain position because of a certain height. All the cores, identical length. Our gearbox core holders, identical lengths. Everything's the same. And I'll move on, which shows a little bit of a cutaway here. So now you can imagine you've got our SLY here underneath, bottom and top slides moving in and out. This gearbox, all it does is rotate these cores. So while it rotates through electronic gearing in our servo controller, we move the top slide back at the same time that it rotates. Thus, we have our pitch. The gearbox at the top is always the same position. All it does is rotate. And then we pull it back electrically here with gearing in our controller to make our pitch. I'll go back to the first picture because there's something that's quite interesting when this runs. Hopefully it will run. All right, I've got to press a button, I think, here to make it run. Yeah, I can't make it run now. Bear with me. I'm going to go back another slide and then jump into that one. And that will make it start up again. So it's now running again. And you'll see that the actual rotating movement only happens when we're unscrewing. The second it's unscrewed out of that thread, we can speed up and pull it back. We just pull it back linearly over the SLY. We've programmed it to know exactly when that thread starts and stops, when it starts to turn and when it stops to turn. These are independent movements to the linear movement. We can control this. This is the most accurate way of unscrewing a core. And the more cores you have, as we all know, you have a lot of cores on a big mold and they all have to be on the exact same height, and you have a profile shut-off face. Those cores need to be not only at the exact right height, but also on the rotational position in the exact same place. This way, we do that. Move back to here, and I'll show you again that the core holder, all of this is made by us in Germany. The white core you see here is made by the mold maker. That's what they do best. Cores and cavities, leave us to the gearbox and the electronics. It's cooled. You can see here we have cooling. We have a cool, we call that a bell around the outside of the core holder. This is flexible. You can have these. We show here only 4 cores. You can have 8. You can have as many as we can fit onto a SLY slide. We can make a wider SLY slide to accommodate more cores. The gearbox just gets longer because nothing changes. We've integrated very stable, I've forgotten what I'm looking for now in English, bearings here, front and back. Angled bearings, I think, you guys will know what they're called. I've completely forgotten the name of them now. There's no adjustability on length, so therefore there's no margin of error. We've manufactured everything. This surface here is manufactured at a specific position. They're all the same. It'll be a position to your shutoff. Then you make your cores. Obviously, as you can well imagine, there's a lot of communication between ourselves and yourselves when a project like this is started up. This is not off the shelf. The gearboxes It's all off-the-shelf design. It's a proven design that works. The SLY, as I've mentioned, there are many hundred of these in the market now in facilities being used. We know they work. We've had zero problems with these systems, other than when somebody accidentally makes a crash or drops one on the floor. That doesn't do them a lot of good. Otherwise, they're running faultlessly since over a year now, since we first brought these out into production. Absolutely faultlessly. So I'm going to move straight on because time is running on. I'm looking at my watch now. I've got another 10 minutes. So unscrewing units. This is basically where Servomold really started. This was like the grassroots for Servomold. We started this many years ago. It's something where the founder of Servomold, Thomas Meister, came up with this idea of unscrewing devices mustn't be so difficult as most people tend to think. There's got to be an easy way around this. I've got a nice little video here showing a mold that we built, so the units to a mold that was built. You can see here two what we call SADs. They're a servo Ausschraub double, because there are two cores. But more importantly, this slide, the threaded core systems. This is our patented self-centering drive system for unscrewing cores. Every unscrewing unit, unscrewing device, whether it's a single unit, whether it's a huge mold with 64 unscrewing cores, always use the exact same principle that we're showing you here. They can be bigger, they can be tiny. It doesn't matter what size. The principle is always the same. The concept is the same. And that concept is very simple, as are most things that are extremely good and well trusted, is a simple design of the gear wheel at the back. This is your drive wheel. This is either attached to a gearbox, driven by a gearbox, or driven by a rack, whichever system you're going to use. But this is your drive. That drive wheel is clamped and supported by two ball bearings in between the plate closing, so that gear wheel will spin freely, but will not move in any other direction other than rotational. Therefore, any pressure put on it by another gear wheel or a rack, all that pressure is taken up in these bearings. We have a patented profile here, rib profile inside here and inside here, where the gear wheel goes over the lead screw. And through the design of this, we are, as in the minute the gear wheel is driving that unscrewing core, it's pushing it into the center. By having the unscrewing core self-centering, you can imagine this is giving you extremely low wear and tear where it matters, and that's over the lead nut. We always have these bronze lead nuts. They can otherwise get a lot of wear and tear if you're always pushing that core slightly to the side with a rack, if that gear wheel is all part of the unscrewing core. They need separated them. It's a patented idea. Help me use it in all of our systems. The little black plate you see here can be of any shape and size. It's the clamping plate for the lead nut when you're adjusting that core height in a traditional unscrewing system. We use a preloaded ball bearing system here to support the front of the core, and an optional DLC coating on the area where the core is running inside the cavity. These will guarantee an extremely low wear and tear and low maintenance on an unscrewing system, which can otherwise be quite high maintenance. As I say, we use this in all of our systems. This is a little breakdown of the double unscrewing device that you saw at the very beginning. We also show the fact that we can supply rotational cooling units to go with it, but it's always the same design. We have here exactly our same patented design, but this time, instead of Pulling these cores back is just another example of how one can unscrew. There's two main ways really on a standard stand-up unscrewing system. This would be a traditional system for caps and closures. We drive the gears through the motor here, but then over the gear wheels, we drive these pillars in our patented unscrewing system. We drive the ejector plate forward at the exact same stroke, same pitch as the thread pitch on your cores. This would be the unscrewing method where cores are always the same length, always in the same position, far easier to adjust as far as shutoffs are concerned. And the plate, the ejector plate, moves forward. Alternatively, we go back to what I showed you at the beginning. We have a gear wheel driven by our motor at the top through idler gears. We have gears at the back. All these little gear wheels are being held over roller bearings, clamped between the plates. So all the pressure, all this sideways pressure is being taken up by these ball bearings. We have a clamp plate holding the lead nut, allowing our cores to go forward and backward in an unscrewing moment. I'm going to move on relatively quickly because I think time is running out and I don't want Mark to suddenly kick me out. This is I love this picture because it's a particularly simple looking mold. It's a 48 cavity lure lock, really standard, a standard in medical industry. Lure locks, lure cones. It's standardized around the world and there's loads of different applications using this thread. This is a 48 cavity one. We made lots of molds identical to this, and it looks really quite simple from the outside. It looks a little bit boring, and I love to move the slide onto this position where exact same mold now without the plates. And as you can see, there's a lot going on. We supply all of this. We can supply just that, so all the gears, all the cores, all the clamping units, or alternatively, the complete moving half. This is where responsibility is then taken by ourselves. It takes the responsibility from yourself. If you wish to make all the cores yourself, also okay. Cores down to where our patented system comes to. It's usually then a two-piece core. So that gives you an idea of what's possible. This is 48. 64, also possible. Makes no difference. It's just growing up to what we've already laid out. It's a standardized system. Another small example of a mold structure showing an 8 cavity with cooling. You can see now when you take the plates away, the cooling that we've got down the sides of the plates are going to the unscrewing cores. So these cores are also cooled, again, with our patented system here, holding the lead nut and lead screw in position. Now, coming to the end now, we can all relax. Richard stopped. I often get asked, yeah, really like this system, looks really cool. We want to go with this. How do we actually switch it on and off? You've got to have a controller. You need a controller. I've got this loop running here, and basically I'll stop it now by clicking on that. What you got, well, didn't stop. Didn't stop. Okay, no worries, I'll let it run. What we have on offer at the moment are 3 standardized sizes of controllers. We've got the mini to the far left, that controls 1 motor. Controls 1 motor, but it can have up to 100 programs. So if you've got molds that only needs the 1 motor, but you run that mold over 2-3 months a year, and you have other molds which also have unscrewing devices or index plates, you can use that same controller for many applications. It's a different program. We'll supply the program, and then off you go. The second size is the one to the right of the mini, is the standard. That will take up to 4 regulators, 4 controllers for 4 motors. Up to, I say that on purpose, up to, you can buy it with just 2. If you don't know what's going to happen down the line, you could be having other molds with 3 or maybe 4. These are upgradable. You 2 or even 1 if you know that it's going to need down the line to upgrade it to more motors. At the back is the rack. That will take up to 8 motors, 8 regulators or amplifiers. And then what just flies down there out of space is our control panel. That's a 5-meter cable. Now, many molders, obviously, square footage is of a premium, and oh, we don't want a controller, we don't have space for it. You can put the controller anywhere. You can put it around the back of the machine, you put it under the machine, you can put it next to your water coolers. They're actually quite small. They don't take up a huge amount of space. They're on 4 little wheels. They move around really easily. The brains is inside this control. As far as servo mold control is concerned, we have new developments coming up for end of the summer, but I'm going to keep that to myself. Hopefully it'll be of interest to you to come and listen to me ranting on for another hour, or maybe I'll keep it a little shorter if we concentrate on one particular unit. But just at the very end of my presentation, this is now the presentation's coming to an end, so to give you an idea of what industries we're supplying most. Obviously medical and pharma is extremely important the last few years. Nevertheless, packaging, electrical, fluid control, automotive has not gone. We're still supplying it, and it makes no difference to us where that mold, where that unit is going to be used. We're not selling specifically or trying to reach out specifically to certain industrial markets. It's whoever needs a clean, precise movement within their injection mold. They need to speak to DME first, and then with us. Company, just as our last slide, another last slide. Oh, loads of these last slides, by the way. 25 years now in action. We have over 1,300 projects running worldwide. I think it's more than that now. Over 45 people now working there in Erbach in Germany, and over 850 control systems running worldwide. That's quite a number. That is really an impressive number of control units. There are very few suppliers of pure control units. You don't control a hot runner with this on the market. I don't think anybody has built that many and has that amount of experience that we have. So I really will now bring it to an end. We're partnering with DME now for many years. I think it's actually more than 5 now. I think it was 5 on the first webinar I did, so it must be about 7 now. I should update that for the next one, Mark. So by all means, feel free to reach out to your representative at DME. They'll get you in contact with us, and let's talk about updating your mold designs to servo. Mark, I think I probably overran it a little bit there.
I think you did all right. It's a great presentation, and visually it looked amazing on here.
Thank you.
Again, if we will stay online if people have questions, so please put them in the chat. Also, I just put into the chat right now, if you want to be notified for the next webinars that we're having with the DME Servo Mold, part of that series. If you just like that message I put in, real quick, I'll make sure that you guys are on the list right now. With that being said, let's go through some of the questions. First one we had here was with torque information. Like, how are torque requirements calculated for proper hardware selection? And where can we find the torque settings?
Okay, we do the calculation. We have our own software that we've developed. Obviously, by doing these now for many years, we've got a lot of experience. So we have, obviously, there's a standard way of calculating shrinkage. There's a standard way of calculating torque for unscrewing or for pulling a core. These are relatively simply available. How we add the experience that we have. As I mentioned, it's really important for us to calculate fully shrunk sizes. So if it's a screw cap and it's a PE, an HDPE, we calculate that particular type of HDPE at cold situation, and then we would know how much shrinkage that is. We'd know how much it is over the core, and we have our program which we can put in, and that will tell us how much torque you would require. Then if it's a 4 cavity or an 8 cavity or 16 cavity, we would multiply it by that factor of number of cores, and through the gearbox we would calculate how much torque is required to move the very first gear. And that would tell us if that motor is going to be. It would also give us the opportunity, if it's a big one and you've got a lot of caps, we would say, no, that's too big. You have the option, a massive electric motor sat on the top of your mold, or we'll just add another gear underneath and run it with 2 molds, one at the top, one underneath. The options are there, and that's why it's really important that if you want a quote from us, please let us have a 3D of your part, or at the very least a 2D drawing of the part, and the spec sheet of the resin. We need to know that, and of course, how many cores are you going to unscrew, and then we will work it out, and we'll tell you. We're completely open with that. That's in the quote, free of charge.
Perfect. Again, if you guys have questions, please put them in the chat. Another question we have is, what are the typical lead times for replacement components?
Ooh, that's a nasty one to answer. Replacement components. Well, we suggest strongly that there's a spare part package ordered. As you can imagine, it's a unique unscrewing core. And it's an 8-cavity mold. You order maybe 5%, so you've got 2 spare cores, but then the molder makes a crash. It crashes all 8 cores. You're going to need all new 8 cores, and they're all individual. It's going to be 10 to 12 weeks. That's a long turnaround. For standard wear components, we have those on stock. Motors, that's not a wear component. A motor will last for ages. Either it breaks pretty well straight away, which is nearly impossible because we do our internal quality control, even though the motor suppliers send us the motors with a quality report, we do check ourselves. We want to be 100% sure that the motors going out are not going to fail. Otherwise, you've got bearings, seals, all those are standard components. Those are within a week or 2 with you in North America, no problem. Perfect. But unique parts, going to take a little while. Order some spares.
Okay. Again, if you guys have questions, let us know, or even after the fact, you guys could send us an email or talk to your DME representative, and we can get back to you on that one. Another question we have is, how many levels of security are there for program adjustments, and are they adjustable?
Exactly. Yeah. As you saw, back if I can on those slides on the controller, we have right here in the middle, that's nice little Servomold logo. That's also the position for an RFID chip. And there are 3 chips. They're on different levels. You can program them how you want, and you can ensure by programming which level that chip has will allow the user a certain amount of access into the program. And that is the security.
Okay, perfect. And then this will be the last question because I don't want to keep everybody too late on here. Again, if you have questions, let us know, and yeah, we'll get back to you. The last questions we have is, do you have a general user manual for the controllers?
Yes, we supply a manual with the controller when we send it out. We've been working a lot on these manuals lately. I know my colleague Daniel and his colleague Sebastian have been doing a lot of work on that to try and make it as interactive and as easy to understand as possible. I'll be the very first to admit, the minute I see these things, I get a little bit scared. It's all touchscreen. You can move stuff around. I'm not the expert on controllers, but you get the support. It's a manual. It's online, it's a PDF, but it's also, I believe, Daniel will have to correct me if I'm wrong, I think you can actually download it even from our website, the manual for the controller, the specific controller that you've ordered. That's always available.
Yes, correct. And we have a lot of video tutorials for the controller as well.
Exactly, the video tutorials, that's really, really handy. Of course, not a lot of you, if you're in the molding shop and you haven't got a laptop in front of you, but you need internet connection. And then, and like I said, there is news to come, quite interesting news on the controller side, but I'm going to keep that as a teaser. It should be of huge benefit to many, many people.
Wonderful. And then also, if you need help with the controller, I know the DME representatives will be able to help you and walk you through it as well.
Definitely.
But in regards to that teaser that you might have coming up, we will be having additional webinars after this. So keep your eyes onto LinkedIn, on DME LinkedIn page, where we'll be advertising when those will be coming. It'll probably in the next maybe about 3 months or so, Richard. Is that what we were thinking
Yes,
about?
that's what I'm guessing.
3
I
months?
think 3 a year is nice, every 4 months. So we're sort of now in May. So yeah, towards the end of the summer, and we can give an
Perfect.
update. And depending on what people really want to talk about, you know, I'm as you can probably tell, I'm happy to talk, but I want to hear you as well. So let's have an open conversation.
Absolutely. We're happy to have you too. So with that, Richard, I want to thank you for the presentation. Daniel, thank you for putting this all together as well. And thank you everyone for joining as well. We will be sending this video out if there's anything you want to get, to listen to again. So you'll have that ability. If you have questions, just reach out to us in that email that I send out, and I'll make sure a DME representative gets a hold of you, and we'll go from there. After that, enjoy the Memorial Day weekend and Victoria Day, and we will see you guys soon. Thank you so much, everyone.
Yes. Have a great holiday, everyone. Thanks a lot for your attention.
Thanks a lot,
Goodbye.
everyone.